In this video, we're going to look at a couple of differentiation techniques with some trig functions. Okay, by now we should already know that when we differentiate sine, we get cos. When we differentiate cos, we get minus sine, and it forms a cycle like this. And we should also know a couple of rules for differentiation. This one's the quotient rule. It's going to be really useful. So when we want to differentiate fractions, we can use this. And these trig functions might be a little bit new to you, but don't freak out when we see these. Like if we talk about sec, it's just 1 over cos theta. Cosec is just 1 over sine theta. The easy way to remember these is the third letter. So if sec, third letter C, I know that's the same as 1 over cos, third letter T, I know that's the same as 1 over tan. Okay, so the first example asks us to differentiate tan x. Now this is a result that you will get in the formula booklet, but we're going to do it like a show question. Sometimes it's a show question. If it just wants you to differentiate it in the middle of another question, you can just remember this answer. But while we first see these, we're going to actually show where they come from. So if it's like a proof question or a show question, we'd have to do this technique. Okay, so we've got y equals tan. First thing I'm going to do is I'm going to write it as sine x over cos x, because I know how to differentiate sine and I know how to differentiate cos. And what we've essentially got now is we've got a fraction. So if I want to differentiate this, I can use the quotient rule. Remember the way the quotient rule works is whatever's on top, you call that u, so u would equal sine x. And whatever's on the bottom, you call that v, so v equals cos x. And then if we want to use the quotient rule, it'd be v times by the u minus u times by the v. So we have to differentiate these separately. So the derivative of sine, we go clockwise, we get cos. Derivative of cos, we get minus sine. Okay, so now we can sub this information in to our quotient rule. So it'd be v times by du, which is v times by du, so it's cos times by cos. I'm going to write that as cos squared minus u times by dv. So u times by dv is sine times sine, but there's a minus, so that's going to be minus sine squared. All divided by v squared, which is cos squared. Okay, so let's, again, this would probably be a show question, so we'd know what we were aiming for, but let's see, we can tidy this up. There's something we can do with this. So we've got cos squared minus minus becomes plus, what's that? Cos squared plus sine squared, that should be familiar. It's one of the first identities we learned in trigonometry, that isn't it? We know that cos squared plus sine squared is the same as 1. There's actually two ways we could do this. Thinking about how much we know about trigonometry, I'm going to do it that way. I'm only going to show you one way. So we've got sine squared plus cos squared. So I know that on the top that's the same as 1 over cos squared. Now look at these new trig ratios. This thing called sec theta is 1 over cos theta. So 1 over cos squared is the same as 1 over cos squared, which is sec squared. So this derivative for tan, if we want to differentiate tan, the answer would be sec squared. Again, don't forget, that's a result that like you need to remember, and it's in the formula booklet, but if it's a show question or a proof question, this is the way we do it. Use the quotient rule, use an identity, and we end up with sec squared. Okay, example 2 is a show question, so obviously we definitely need to show our method to this. So it says show if y is equal to cosec, then dy by dx is equal to minus cosec cos. Now don't get freaked out when you first see this, don't forget cosec. We know cosec is just 1 over sine, so this is basically saying, look, differentiate 1 over sine. And you always want to refer back to sines and coses because we know how to differentiate sines and coses. So the first thing I would do is write, instead of thinking about cosec, we could write it as 1 over sine. Now we've actually got two options in how we differentiate this. It is a fraction, so we could use the quotient rule. But the quotient rule is really useful when you've got like a function on the top and a function on the bottom. What we've really got here is just 1 over sine. I'm going to show you two ways to differentiate this, and I'll let you decide which one you prefer. So we could write it as a bracket to the power, like it's just sine x to the power minus 1. And if you're good on the chain rule, this is a really quick way of differentiating this. If you remember how to differentiate a bracket to a power, times by the power. You've also got to look at what's inside now, and times by the derivative, which would be cos. And then take 1 off the power. Okay? So that would give me minus cos x on top. And if sine to the power minus 2, that's like having sine squared on the bottom. I'm going to pause at that point. We'll get to this answer in a second. I'll show you the other way as well, because we'll get it the same way using the quotient rule. So if you prefer to use the quotient rule, then remember u is just equal to 1, v is equal to sine x. So du by dx would be 0, dv by dx would be cos. And then if we use the quotient rule, so it's v times by du, so that times by 0 would just be 0, and then minus u times by dv, so that's 1 times by cos. And then that's all divided by v squared, which is sine squared. You might actually argue that this is quicker than doing the bracket to a power, because look, we get the same answer. It's up to you. Knowing both techniques is going to be really important for the A level anyway, because depending on the question you have to use different techniques. So we've got minus cos over sine squared, minus cos over sine squared. Look at the answer we're trying to get to. Okay, with a show question, quite often it's useful if you check your answer and work backwards a little bit. So if I was trying to get to dy by dx is equal to minus cosec cos, we could sort of work backwards a bit and think, well, what do we know about cosec? Cosec's 1 over sine, so that'd be minus 1 over sine times by cos. Cos is 1 over tan, but to be honest, you don't really want to use 1 over tan because everything else is in terms of sine and cos. It's better to think about it as cos over sine, so that'll be times by cos divided by sine. And let's check what we've got. Well, that's the same, isn't it? Like we've got minus cos divided by sine squared. So what if you weren't going backwards, if you were going forwards like this, what you'd have to realise is this, we could write as minus 1 over sine and then times by cos over sine. That's just how fractions work, isn't it? If you split it up, you just times the tops and times the bottoms. So that's sine squared, we can think about it as sine times by sine, and that's where these two different functions come from. Okay. Okay, example 3 is a little bit of a different style question. It just says differentiate, it's not a show question. So like, don't worry about doing like a quotient rule or anything with the cosec, okay? If you look in the formula booklet, it tells you that if the function is cosec, then the derivative is minus cosec cos. So we just want to use that result in this question because there's enough going on. It's divided by x squared. It's not a show question. You can just essentially, if you want to differentiate cosec, you should just know that, well, the derivative is minus cosec cos. Okay, so I'm going to do the quotient rule. We've got a fraction, it's a function divided by a function. So u would equal cosec 2x, v would equal x squared. Let's do this one, it's a bit easier. dv by dx would equal 2x. Now you've got to be careful with this one. Maybe a little side question. If I said y is equal to sine of 2x, what would the derivative of that be? Remember the shortcuts for the chain rule? Like if I differentiate sine, I know I get cos. But because it's 2x, we multiply the front by the 2, the derivative, don't we? Which is just a shortcut for the chain rule. Same thing's going to happen on this one, okay? Because we've got cosec of 2x, and that result is only for x. So du by dx. I know if I differentiate cosec, I get minus cosec 2x cos 2x. And because it's a 2x, the chain rule tells us that when we're differentiating, we multiply by that coefficient. Okay, so differentiate, and let's see if we can add this up. I'm not sure what we're going to end up with, but we've got dy by dx. So it's v times by du, so that'd be minus 2x squared. Always put the numbers at the front and then the algebra next, and then the trig afterwards. Minus u times by dv. So that would be, I'm going to write that as 2x cosec 2x, and then that's all divided by v squared. So if you do x squared squared, you'd get x to the power 4. Now again, it doesn't say how to leave your answer, but one thing we probably should do if we want to get full marks on this question at least, you notice that essentially what you've got here is there's 2 terms on top of this fraction being divided by 1 term, and they all have a common factor of x. So the bare minimum we should do is cancel out this common factor. You could probably take a 2 out of both as well. So if I take a 2 out of the 2 terms on the top, if I cancel an x from everything, I'd be left with x cubed on the bottom. Cancel an x from this, I'd be left with, I'm taking the 2 out as well. Ooh, wait, are they both negatives? Yeah, I'll take the minus 2 out. So if I take a minus 2 out of this and I cancel an x, then I'm left with x cosec 2x cos 2x. Now I've taken the minus out and the 2 out, and I've cancelled an x, so that would just leave me with plus cosec 2x. I suppose there's also an argument, because both of these terms have got cosec 2x in, you could take the cosec 2x out as well, but I'm going to leave it like that for now. Okay. Okay, last example for this video, we want to differentiate sec cubed. Okay. A lot of people struggle with questions like this because it's just, you don't quite see exactly how you're going to start it. The first really important thing to realise is that you've got a function inside another function which is perfect for the chain rule when you want to differentiate. So what we need to do to be able to differentiate this, we need to remember our shortcut for our bracket to a power. Okay, we times by the power, we times by the derivative, and we take 1 off the power. So the only thing I really need to know for this question is what's the derivative of sec. And again, if you look in the formula booklet, it tells you if I want to differentiate sec, I get sec x tan x. So as long as I remember my shortcut for the chain rule, it should actually be quite an easy question. Okay, so bracket times by the power. Look at what's inside and differentiate it. So our derivative would be sec x tan x, and then your bracket, you take 1 off the power. Okay, so let's just tidy this up. We've got sec squared, and that's times by another sec as well, so that would be 3 sec cubed x tan x. Okay, hopefully that was useful. Thank you.